Do an example for Bernoulli equation. So Bernoulli equation example. The classic example typically used to illustrate the use of the Bernoulli equation is flow out of a reservoir or a tank. So let's say you have this large container that is open to the atmosphere, atmospheric pressure over here, and it is kind of being vented at the bottom. So there's this flow coming out, there's this jet of water coming out, and the question is to find the velocity over here. What is the exit velocity? So what we're going to do, we're going to pick a streamline from this point to that point over there, which probably looks like this. And we're going to assume the flow is steady, quasi-steady, inviscid, and that there is a streamline over here. So the Bernoulli equation tells us we can apply this energy balance from station 1 to station 2, and we're going to call this height over here Z1 and this height over here Z2. Okay, so the Bernoulli equation tells us that P1 over rho water plus V1 squared over 2 plus GZ1 is equal to P2 over rho water plus V2 squared over 2 plus GZ2. Now, since this jet is open to the atmosphere and this surface up here is open to the atmosphere, and assuming that the height is quite small, we can clearly assume that P1 and P2 are equal. So P1 is approximately equal to P2. So we eliminate this term. And this V1 squared at the top of the surface, again assuming quasi-state conditions, this is a very small velocity relative to V2, so we're going to assume this to be 0. So what we're left with is V2 squared over 2 is equal to GZ1 minus Z2, right? And then V2 squared is equal to 2GZ1 minus Z2. If we call this difference over here, if we call this H, which is just basically the height, initial height of the tank, or the height of the tank, and that gives us V2 is equal to square root of 2GH, a classic result for flow out of a tank through an orifice.